Hello everyone, welcome back to the channel Code with AKJ. Today is day 56 of solving LeetCode 75 challenge, and today's problem is the last problem from our binary search chapter. So this is a very famous problem, mostly asked in interviews, so make sure you watch this video till the end. So before moving on to the problem statement, make sure to like, share, comment and subscribe to the channel for daily DSA and LeetCode content. So let's get started. So the problem statement says Koko loves to eat bananas. There are n piles of bananas. The ith pile has piles of I bananas. The guards have gone and will come back in H hours. Koko can decide her bananas per hour eating speed of K. Each hour she chooses some pile of bananas and eats K bananas from that pile. If the pile has less than K bananas, she eats all of them instead and will not eat any more bananas during this hour. Koko likes to eat slowly but still wants to finish eating all the bananas before the guards return. So return the minimum integer k such that she can eat all the bananas within h hours. So this is the problem statement. So let's try to understand what the problem statement is all about. So we are given n piles of bananas and piles of I is the bananas in the ith pile. So for example, this there are four piles in this piles array and each pile has a set of bananas. So the first index has three bananas and the second pile has six bananas and so on and so forth. And we have h hours before guards return. So Coco chooses a speed k bananas per hour, which means it can eat a set of bananas per hour, which is denoted by integer k. And the rule here is in 1 hour she eats only one pile. If suppose the Coco can eat two bananas per hour, then if she tries to eat this first pile, then in the first hour she'll be able to eat only two bananas. Then she'll use another 1 hour to eat left out banana, which is one. So Coco will take 2 hours to complete this particular pile of bananas. So our goal here is to find the minimum integer k, which is number of bananas per hour she can eat, such that all bananas are eaten within h hours. Which means we need to make sure to find that minimum integer k, which is the speed of eating bananas per hour, so that she can finish all the piles of bananas before the guards return. So this is all about our problem statement. So let's quickly go through all the examples. So here I have taken all the three examples of our given problem statement. So the key observation from our problem statement here would be that for a given speed k, the time taken for one pile to complete would be the ceil function of piles of I divided by k. So we'll take the upper bound value. So for that we'll use ceil function. So this would be our main observation from this problem statement, that the time taken for the Coco to eat bananas per hour with a speed limit k would be the ceil function of piles of I divided by k. So the first approach or the brute force approach of this problem statement here would be to try all the possible speed starting from value 1 till the maximum of the piles array. So the maximum speed of eating bananas could be the maximum number of bananas present in piles of I. Suppose the Coco will eat the bananas with the speed 1 bananas per hour. So let's do a quick run on our first example. There are 3 bananas in our first pile. So it will take 3 hours to finish the first pile of bananas. Coming to the second index, it will take 6 hours to finish the second pile, and in the same way, it will take 7 hours to finish the third pile, and it will take 11 hours to finish the fourth pile. The time taken to finish all the piles would give us value 27. So the total time taken by a Coco to finish all the bananas here is 27 hours. And the limit here given to us is 8 hours. So this speed is too slow to finish all these bananas within H hours. So let's try to increase this particular speed from 1 to 2. So to finish our first pile, the speed 2 bananas per hour, the time required to finish the first pile would be 2 hours, which is explained here. So in the first hour, it will eat 2 bananas, and in the second hour, it will eat 1 banana. So the total time taken here to finish the first pile would be 2. And coming to the second pile, it will take 3 hours. And for the third pile, it would take 3 hours. And the last pile, it will take 6 hours. So again, the total time taken here is 5 plus 3, 8, 8 plus 6, 14 hours. So again, it is greater than our h value, so we need to increment our speed. So let's try 3. So the time required to finish our first pile here would be 1, and the time required to finish our second pile would be 2. Time required to finish the third pile would be 3, and time required for fourth pile would be 4. So the total time here would be 10 hours, which is still greater than h value. So again we need to increment our speed, which is 4. So let's try with 4. So the time required to finish our first pile of bananas with the speed 4 bananas per hour would be 1. Again the second pile would be 2. The time required for third pile would be 2, and the time required for the fourth pile here would be 3. So the total time here would be 8. So it is equals to the h value. So we'll return 4 as an answer. So this would be our first approach. So the time complexity of this approach would be n cross max of piles. And for every value from 1 to max of piles, we are traversing the whole piles array and we are calculating the total time and we are comparing it with our h value. So in this way, the total time complexity here would be n cross max of piles of array. And coming to the space complexity remains constant. So this would be our first approach or the brute force approach where we are trying all the possible speed from 1 till max of piles of array. So let's quickly move on to the code of this approach and let's submit. So this is the code for our first approach where we are trying each and every possible speed starting from 1 till the maximum element of our piles array. So here I have stored the piles array size. I've also calculated the maximum value inside our piles array with the help of star max element inbuilt function, and we'll run a loop from 1 to max and we'll check if Koko can eat all bananas for this particular speed I. We'll send our piles array and we'll also send our h as a parameter to our function. And whenever we find that for this particular speed I, we were able to finish all the bananas within our time limit h, we'll return that speed value which is stored in I variable. And after looping all the possibilities, if we still didn't find a particular speed limit where we can finish all the bananas, we'll return -1. So let's look at our can eat all bananas function. So we'll take a variable total time which would be initially 0. We'll run a loop inside our piles array. We will calculate the total time by adding up the time taken to finish each pile. So instead of using ceil inbuilt function, I have used this particular formula which is similar to the ceil division. So you might get a doubt why didn't we use ceil directly. So generally it has three drawbacks. While dividing piles of I directly with it, we might get some floating values, and converting that floating values to the integer will take a lot of precision errors, and it is also slower comparing to the integer division. And the third drawback here is unnecessary casting, that is converting the piles of I which is in integer into double and then doing the division. So this is why we haven't used ceil inbuilt function directly. So this particular formula is similar to the ceil function. So after adding up each and every pile's time into our total time variable, based on this particular condition will either return true or false. This is all about the code of our first approach. So let's quickly run this code. So yeah, it's working. So let's submit. As you can see, this approach gives us time limit exceeded because of the time complexity, which is too high for our constraints. So the piles of I value could be a maximum 10 power 9. So for the value 10 power 9, our approach which uses O of n cross max C time complexity would give us time limit exceeded. So let's try to optimize our approach and reduce our time complexity and use binary search algorithm in this problem statement. So now let's move on to our optimal approach where we will be using binary search algorithm. So the key observation here we can see here is that the minimum integer k is lying between the value 1 till maximum variable, which is the maximum element of our piles array. So the integer k is lying between this particular search space. If suppose in this given range at this particular point at this particular speed k we were able to finish all the bananas, then any speed greater than this particular value would also work. So in the same way, if we were not able to finish all the bananas with this given speed, then all the values which is less than or equal to this particular value will also not work. So this monotonic behavior allows us to apply binary search. So generally the main rule of our binary search here is the array should be sorted order. If we observe in these given two examples, the second example and the third example, the array is not sorted, but still we are trying to use binary search. So based on the search space, we are trying to use this binary search. So the search space here is from 1 to the maximum value, and we are trying to reduce this search space depending upon the k value. So let's move on to the logic of this binary search algorithm. So since we know that the search space here is from 1 to the maximum value, so here maximum value is 11, we'll consider this as a low pointer and we'll consider this as a high pointer. And according to our binary search algorithm, our first step here is to find the mid pointer. So we'll find a mid value with the help of the formula low plus high minus L by 2. And we'll check for this given mid pointer, are we able to finish all the bananas within H hours? So if we are able to finish all the bananas, then the values which is greater than mid value is also be considered as a valid answer. But since we need the minimum integer k, we'll try to move our high pointer to mid minus 1. So we'll try to search in the left search space. We'll ignore all the right search space values since we need the minimum integer value. In the same way, in the next iteration, if we were not able to finish all bananas within h hours, then we'll move our low pointer to mid plus 1 and we'll try to search in the right search space, as the values below this mid pointer will not give us our required result. In this way, we'll be using binary search to find that particular minimum integer k value where we can eat all the bananas of piles array within h hours. So I hope you understood this logic of our optimal approach. So let's do a quick dry run on this given example and then we'll move on to the code. So now let's do a dry run on this given example. Our low pointer would be pointing to 1, high pointer would be pointing to the maximum element which is level here. So the first step here would be to find the mid value. Mid value would be low plus high minus low by 2. Low here is 1, high value is level minus 1 by 2. 1 plus 10 by 2 which is 5, which gives us 6. So the mid value what we got is 6. So we'll run a loop inside our piles array with the speed 6 bananas per hour. So we'll check whether we are able to finish all the bananas with the speed 6 and the total time taken is less than or equals to h or not. So the time required to finish the first pile with the speed 6 would take 1 hour, and for the second pile it would take 1 hour, and for the third pile it would take 2 hours, and for the last pile it would take 2 hours. So the total time here taken to finish all the bananas is 6, which is less than h. So this could be our possible answer. So since with the speed 6 we were able to finish all the bananas, we'll try to ignore all the values which is greater than 6, which means the values which are in the range 1 to 11. We found a mid pointer value 6 and we were able to finish all the bananas with this given speed. So we'll neglect all the values which are greater than 6 till level. So now we'll try to search in this given range which is from 1 to 6. So now let's quickly update our high pointer which would be pointing to mid minus 1. So low would be 1, high pointer would be 5. So again we'll find our mid pointer which would be low plus high minus low by 2, which is 1 plus 5 minus 1 by 2, which is 3. So now we'll check with the speed 3 bananas per hour. Are we able to finish all the bananas inside our piles array? And the total time taken is less than or equals to h or not. So this was for the speed 6 and now we are trying to check with the speed 3. So the time required to finish the first piles of I with the speed 3 would be 1 hour. It would take 2 hours to finish the second pile. It would take 3 hours to finish the third pile, and it would take 4 hours to finish the last pile. So the total time taken here is 10 hours, which is greater than h. So with speed 3 bananas per hour, we were not able to finish all the bananas inside our piles array. So we'll update our low pointer, which is to mid plus 1. So the updated pointers here are low would be pointing to 4 and high would be pointing to 5. So again we'll find our mid pointer, which is low plus high minus low by 2, which is 4 plus 5 minus 4 by 2, which is 4 plus 0, which would give us 4. So now we'll try to check with 4 bananas per hour. Are we able to finish all the bananas inside the piles array? We are able to finish the first pile in 1 hour, the second pile in 2 hours, the third pile in 2 hours, and for the fourth pile we are taking 3 hours. So the total time here taken to finish all the bananas is 8 hours, which is equals to our H value 8 hours. Since we are able to finish with this given speed, let's try to update our pointers again. So we'll decrease our high pointer to mid minus 1. So when we try to update our high pointer to mid minus 1, the high pointer would be pointing to 3 and low pointer is pointing to 4. Since they pass each other, we'll try to stop our iteration. So hence we have found our minimum integer k, which is 4 bananas per hour, where Koko can eat all the bananas within h hours. So this is how the optimal approach works, where we have used binary search algorithm to find out the minimum integer k such that Koko can eat all the bananas within h hours. So coming to the time complexity of this approach, since we are again running a loop inside our piles array, definitely it would take n time complexity. And since we are using binary search algorithm, that is for every mid pointer we are trying to run a loop inside our piles array. So the time complexity here would be log of max of piles array. So the total time complexity of this approach is n cross log of max of piles array. And coming to the space complexity, the space complexity remains same, which is constant. So let's quickly move on to our code and let's submit. So here's the code for our optimal approach, where we have used binary search algorithm. So the search space remains same, that is will start from 1 till the maximum element of our piles array. So again we have found the maximum variable. Here we are using binary search algorithm. So according to the binary search algorithm, we'll be having two pointers. One would be low pointer and another would be high pointer. So low will be pointing to 1, high pointer would be pointing to maximum variable. We'll store the answer variable with the maximum variable, and we'll run a while loop until or unless low is less than or equal to high. We'll find our mid pointer and we'll call the function. And if we were able to finish all the bananas with this given speed, then we'll store that inside our answer variable and we'll move our high pointer to mid minus 1. And with the given speed mid, if we were not able to eat all the bananas within h hours, then we'll move our low pointer to mid plus 1. Can eat all bananas function remains same, which calculates the total time taken to finish all the piles of I with this given speed eat. So let's quickly run this code. It's working, so let's submit. As you can see, this approach gives a successful submission because of the reduced time complexity compared to the brute force approach time complexity. So the brute force approach time complexity was O of n cross max of piles, and with the help of the binary search algorithm, we have reduced it to O of n cross log of max of piles. With the help of the search space and reducing the search space based on the mid pointer, we have drastically reduced the complexity. And that's how binary search helped us to reduce time complexity from linear to logarithmic. So with this, we officially complete the binary search chapter. So this was the last problem statement from the binary search chapter. So if you have reached till now, that's a massive progress. So great job on that. And don't forget to like, share, comment, and subscribe for the next chapter. So the next chapter here is backtracking, and there are two problems under this chapter. So I'll see you in the next video. Until then, keep coding, keep growing. Thank you.